Welcome back to the conclusion. So we're going to go over the last question. Find all values of x for which the function f of x equals x cubed minus 8 divided by x squared minus 4x minus 5 is differentiable. So the problem is, where is the denominator 0? That's where we're going to have discontinuities. You might wonder, is that discontinuity going to be a whole or an asymptote? Well, it's going to be an asymptote because nothing's going to cancel out. The numerator, if we were to factor that, what happened there? Never likes to write the first time. It's like it doesn't remember. Doesn't remember how to write. There. F of x equals, so the numerator factored would be x minus 2 times, so you're going to have an x minus 2, right? You're not going to have an x minus 2 in the denominator, so it's definitely, nothing's going to cancel out. And then x squared plus 2x plus 4. All right, so that's what that would factor to in the numerator. And it will not cancel with anything in the denominator, which would be x minus 5, x plus 1. Right, that's what that is factored. And that thing at the end is not a question mark. That, believe it or not, is a parentheses. All right, so, but whether it was a hole in the graph or whether it was an asymptote wouldn't make any difference in terms of differentiability, right? Not being continuous is not being continuous. It doesn't matter what the type of discontinuity is. So the graph is not differentiable because it's not continuous. Oh, by the way, all these questions were in your notes as well. That's why I went over all the answers, so that you could write down the answers. And so it's not differential because it's not continuous. So right here we're going to have an asymptote at x equals 5, and x plus 1 equals 0, x equals negative 1. So not differentiable at x equals negative 1 and x equals 5. Right? It is differentiable because it is continuous, and there's no cusps or corners on the graph of a rational function. So it's smooth everywhere else. So that would be negative infinity to negative 1, and negative 1 to 5, and 5 to infinity. All right? So all of these, I believe all of these were in your notes, and so make sure you wrote them all down. And you can always rewatch any of the videos and just pause if I went too fast over any of the answers. And as always, you can ask me any questions you want in class. But this is the end of my video and the last problem I had. All right, so I hope that this has made continuity and differentiability much more clear for you. And you'll be able to recognize when a graph is differentiable and when it's not at some given x value. All right, bye for now.